Hello, welcome back once again. Today we're given the following equation. A single equation with two different variables, a and b, and we're asked to solve for the value or values of a that will satisfy this equation. Remember that this type of equation is called Diophantine equation, and we're expected to find the integer solutions, right? So let's get started. Now we're going to use the following trick. At the left hand side we'll have 15 raised to the power of a, of which we can write this as 15 raised to the power of a all over 2, and then we have to square this, right? We know if you apply this property, a raised to the power of b in bracket raised to the power of c is equal to a raised to the power of b multiplied by c. If you multiply a by 2, the 2's will get cancelled and we're left with a, and that will give us 15 to the power of a. Then we're going to subtract 13 raised to the power of b. We're going to use the same property, so we get 13 raised to the power of b all over 2, and then we square this, so this is equal to 56. Now if you take a look at this left hand side, we have difference of two squares, right? So we're going to use the following formula. Now using the following formula for difference of two squares formula, we get a squared minus b squared. This is equal to a plus b multiplied by a minus b. So this left hand side becomes 15 raised to the power of a by 2 plus 13 raised to the power of b by 2 multiplied by 15 raised to the power of a by 2 minus 13 raised to the power of b by 2. So this is equal to 56. Now let us make the following substitutions. We're going to let 15 raised to the power of a by 2 equals m, and then 13 raised to the power of b by 2 equals n. If you square both sides, we get 15 to the power of a is equal to m squared. Here we get 13 to the power of b is equal to n squared. We obtain the following: m plus n multiplied by m minus n. This is equal to now 56. We can factor 56 as follows. Either we use 8 times 7, or we use 1 times 56, or we use 2 times 28, or we use 4 multiplied by 14. Remember, we are solving for integer solutions for a and b. Therefore, we're expecting m and n to be positive integer, right? So now, in our first case, we have where m plus n multiplied by m minus n is equal to 8 times 7, right? So here we know m plus n for positive integer must be greater than m minus n, right? Therefore, we're going to set m plus n equals 8, and then m minus n equals 7. To solve for m, we add both equations to eliminate n. So we get 2m at the left hand side. This is equal to 8 plus 7. So 8 plus 7 here is going to give us 15. So we can see there is no positive integer for m here, right? Because if you divide 15 by 2, it will have a remainder. So let's check 2 times 28. So since m plus n is greater, so we're going to set m plus n equals 28, and then m minus n equals 2. Add both equations, we get 2m is equal to 30. Divide both sides by 2 here, we get m is equal to 15, right? For n, we subtract 15 from 28, we get n is equal to 28 minus 15, and that is giving us 13. Now for the other ones, if you add 1 and 56, that will give us an odd number, so there is no integer solution. When you add 4 and 14, that will actually give us 18, and we divide, that is solving for m will give us 18 divided by 2, which is 9. And if you check here, 15 cannot be expressed in index power of 18. Also 18 cannot be expressed in index power of 15. So the only solution here is where we have 2 times 28. So now let us go back to this substitution here. So 15 raised to the power of a is equal to m squared. So this implies that 15 raised to the power of a is equal to m, which is 15. That will be 15 squared. Since we have the same base, we're going to equate the exponents. So this implies from here that a is equal to 2. Now remember that 13 to the power of b is equal to n squared. It also implies that 13 to the power of b is equal to n is 13. So this will become 13 squared. The same base, equate the exponents, we get b is equal to 2. So therefore, we have a is equal to 2 and b is equal to 2. Now let us cross-check if this satisfies the original equation. Remember, our equation is 15 to the power of a minus 13 to the power of b. This will give us 56. When you substitute the value for a and b, we get 15 squared minus 13 squared. This is giving us 225 minus 169. So when you subtract this, this is obviously going to give us 56. So therefore, a is equal to 2 and b is equal to 2. Thank you for watching. If you enjoyed the video, kindly subscribe. Also like, comment, and share.